So let's say we're given the following to evaluate, or not to evaluate, to decide whether it converges or not. Okay, so we have this for n going from 2 to infinity of 1 over n squared plus 4n, and this is under a square root sign. Okay, so this is our a sub n, all right? And then this is kind of where you have to get creative a little bit. So we're going to use b sub n on this problem. And this 1 over n, okay, side note, okay, I'm going to go on a little tangent here. So side note, whenever you have the infinite series of the following of 1 over n, this is called a special term called harmonic series. Okay, so this is the pretty familiar one where you just see like 1 over 1. So that's 1 plus 1/2 plus 1/3 plus 1/4. So your n is just on the bottom, right? So that's just a side note. So from here, we're going to, like I said, we're going to use the limit comparison test. So this is our a sub n, and this is our b sub n. So the limit that we're going to construct is capital L equals limit as n goes to infinity of a sub n, so 1 over square root of n squared plus 4n, over, big dividing sign, 1 over n. This is our a sub n over b sub n, okay? And then we'll just simplify this. So limit as n goes to infinity of 1, well, I'm just going to write the n on top, because this 1 over n on the bottom here, it's going to flip up, right? Because dividing by a fraction means you multiply by its reciprocal. So then we have n over the square root of n squared plus 4n. And then to simplify this, I'm just going to multiply times 1 over n on both top and bottom, just to get rid of the numerator here. So we have limit as n goes to infinity, and this top thing cancels out to 1, which is nice. And then we also have this 1 over n on the bottom. And what I'm going to do now is we can actually bring this inside a square root, right? You can always do functions backwards. So I'm going to bring that inside. So when you bring a number or variable inside of a square root, you have to square it to get it in there. Okay, another side note. So to get 3 inside of a square root, then you just square it. Okay, so that's the whole concept. What I did here is with this 1 over n, I just squared it to get it inside. And then I'm going to multiply it times everything else in there that was already there. Okay, so then, okay, ignore that. That's just decoration now. Okay, so then we have limit as n goes to infinity of 1 over, now I'm going to distribute this here and here. So this n squared over n squared, that turns out to be a 1. And then this is a 4 over n. Okay? So now at this point we can just plug in infinity for n and see what we get. So we have 1 over 1 plus 4 over infinity. And this term, as we know, tends to 0, right, in the long run. So then our big L is going to equal 1. So big L, slanted line, equals 1. Which, by the 3 cases, this is greater than 0. So this is the first case, right, that I went over. So we don't need to know anything else except for, okay, going back to the side note, sorry. I almost forgot the most important part. So this harmonic series, it actually always diverges, okay? It diverges as an infinite sum just because as it's decreasing, each term is decreased by n amount, or I don't know how you want to think of it, but basically as it's decreasing, because each term is smaller than the next, right? The next one would be 1 over 5, and the next one 1 over 6. But these, the increments of decreasingness, it doesn't decrease fast enough, basically, to 0. So the number is too significant, and it doesn't converge. So since we know that n equals 1 of b sub n, so this is like our b sub n. So since that diverges, And according to this L is greater than 0, then A sub n must do whatever the other one does, right? So we conclude that the infinite series of A sub n, so 1 over square root of n squared plus 4n, must diverge as well. Okay? All right. Well, and you can also add in, I mean, just if you feel like it, or if your professor requires it, I don't know the protocol, but you can say by the limit comparison test, because that's what we did here. We compared these two sequences using a limit. So by the limit comparison test. Yeah. I just abbreviated for sake of space. But, okay.